In the 1950s, the BOYAR-SCHULTZ company began manufacturing their Model SK cross-slide knurling tools. They come in a variety of small sizes, making them ideal for turning small parts right up against the lathe collet or head. They are spring-loaded, self-centering, easy to adjust, and because they have dual rolls, put minimal force on the work being knurled. Knurl rolls come in a variety of patterns, the most common being straight, right-handed, and left-handed. The right-handed and left-handed knurl are used in combination to create a diamond pattern on the work. I decided to make a bar that would fit my standard 1-inch boring bar holder for the CNC lathe. I drilled through it and put a screw up the middle to act as a drawbar for the tool. This would allow me to reach a hex wrench through the turret and tighten the knurl in the correct position. I really like this stop lock for setting lengths of material, and it's repeatable. Most of the work was done on the Knurling manual lathe, and these machines have been around for quite a while. Started off by facing it and then pilot drilling it. After the pilot drill, a 1/2-inch drill was run down through the center, and you can see that the tailstock moved on me just a little. I was working a little bit fast, and I probably need to tighten the clamp. After it was drilled, the standoff on the front to give it a little bit of protrusion was done, and then flipped around and faced off on the back and then chamfered. Here I'm drilling the counterbore with a Silver and Deming reduced shank drill. A counterbore is the recess for the head of the screw. Let's pause for a quick history lesson. In the 1800s, the Silver and Deming Manufacturing Company of Salem, Ohio, developed a reduced shank drill so that big drills could be used in smaller chucks. They didn't patent the idea, and soon others copied it. Here we are, over 100 years later, and we still call reduced shank drills Silver and Deming. Learn something new every day. Now back to our regular program. Making the bottom of the counterbore flat for the screw head. The CNC lathe uses VDI 30 tooling, and I'm going to use a 1-inch boring bar holder to hold this bar, and I need a flat for the set screws. I'm glass bead blasting the part to soften the tool marks and make it ready for parkerizing. I find parkerizing to be a very effective way to protect shop-made tooling and to make it look a lot more professional. Here, the hot plate temperature, 94 degrees Celsius, is regulated by a homemade controller. Once it's done, remove it and dip it in oil, and then wipe off the excess. Professional. The new bar is installed in a 1-inch boring bar tool holder in the turret of the CNC lathe. The knurl is then brought up to the work and centered, and then the draw bolt is tightened using a hex wrench through the turret of the lathe. It's worked out very well. Here I'm forming straight knurls for thumb screws on the CNC lathe. The spindle's going about 500 RPM. I don't recall the feed, but it worked out well.